All right, and our study of the coordinate plane is going to continue, and we're going to talk about distance in the coordinate plane today, which once again is really something you already know. So you can see standard 10.2, I can find the distance between 2 points in the coordinate plane. All right, and so a lot of what we're doing is really helping you try to make connections to what you already know and try to transfer that knowledge into a new context. All right, so to kind of get you thinking about things, let's look at an opener here. So Boulder is one of many cities that are designed on a grid. Do you know where Boulder starts counting its streets from? Example, 9th Street, then 10th Street, then eventually 28th, etc. All right, so think about that, right? If it's designed on a grid, and then how would you do this? All right, so suppose we are in a city where the center is at 0, 0. You have a building at negative 3, 4. All right, and a second building at 2, 3. What are some ways you can find distance between the two buildings if each unit is the length of a block, right? Okay, all right, so pause the video, just give that some thought, flip the video back on, and we'll see what you came up with. All right, so maybe you sketch something, right? So if we draw our coordinate plane here, here's 0, 0, right? Negative 3, 1, 2, 3, 4 would be like right here, right? And then we'd have 2, 3, which would be here. So we could have this distance, right, like that. That's what we really want to find, right? So, and so distance is that straight line, right? Like as the crow flies, maybe you've heard that, right? Okay, so between 2 points, right? Okay, you know what I thought about was like, well, you could get down, and I've seen them on the highways, right? They have like those little wheels, and they're rolling them, right, to measure the distance. Not necessarily very good because you'd have to go up and over buildings or through buildings, so not necessarily the most effective way of measuring distance, right? So what are some things that you did? So maybe, just maybe, some of you thought, well, I could kind of count down and across like this. All right, and said, oh, I'd have to go, if I start at this one, maybe I have to go south 1 block, all right, because I'm at 4, right? And then I have to go over, right, so I'm gonna go down to this intersection, then I'm gonna go over this way, right? And then if I go from negative 3 to 2, then I went 5 blocks, all right, east, all right, to the right. Or you could have reversed it, right, and gone up and then to the left 5, right? And so that, notice, is a way of trying to find distance, right? So you can say, oh, I had to go a block south, I had to go 5 blocks east, all right, to get there. Okay, that's not necessarily the distance between the two buildings, but notice what we form when we do that, all right? And this is really what we want to get at. By doing this, we form a right triangle. And then that distance, all right, that we're looking for right here, all right, is the hypotenuse of a right triangle, which means, right, that it's really a right triangle problem, all right? And we have a tool to solve, all right, a right triangle from missing that hypotenuse, and that's the Pythagorean theorem. So really all distance is, all right, is turning it into a right triangle problem, so we can use a tool, all right, a very powerful tool, the Pythagorean theorem, all right, which we already know or should be getting to know very well, all right, to solve this problem. So that's what we're going to look at today. So distance, right? Okay, so it's the, all right, length of a straight set line, and it's really kind of a segment, line segment here, because it doesn't keep going from one point to another, right? Okay, so the length of a straight line segment from one point to another, right? So we know it's that straight, it's not bent, it's not curved, there's no angle to it, right? It's not wobbly or wavy, all right? And so it's just like whatever 2 points you pick, right? We're going to find that straight distance, right? That's our distance, right? Okay, and then hypotenuse, right? And that's really what we get. And this is the side opposite the right angle in a right triangle. All right, so if we draw our right triangle, right, we typically let that be C, right? That's the hypotenuse. All right, and so when we think about that, right, if we know the two legs, we can always find the hypotenuse through our Pythagorean theorem, which we know is a squared plus b squared is equal to c squared, right? So if I try to draw that right triangle again, so A, B, and there's C again. And it doesn't matter which leg is A and which leg is B. What always matters, though, is that C has to be the hypotenuse, okay? And so notice then if I go back up to our problem, right, I created this right triangle, all right? So notice the vertical leg is 1, the horizontal leg, all right, is 5. And so I could go 1 squared, plus 5 squared is equal to d squared. All right, so 1 plus 25 is equal to d squared. All right, so this is 26 is equal to d squared. And I could take the square root of both sides, and I'm going to get like 5.1, I think, here. All right, would be my distance. All right, so it'll be about 5.1 blocks if that's how we're measuring, and that's why I kind of put length in parentheses down there because we don't know what the unit is, right? So whatever that is, all right, 5.1 units, all right, and that's all it is. And so notice we've done this problem a lot already this year. So once again, taking something you already know and then translating that into a new context and using that in that situation. So let's go ahead and flip the page and look at, all right, some notes here. All right, so finding the distance between 2 points. So all right, so let's say we want to know this distance here between B and C, right? So what we want to do is we're going to create that right triangle. So we're going to draw in those vertical and horizontal legs to create our right triangle, which we already have done in our picture here, okay? And that creates a right angle, all right, which creates our right triangle, okay? And then notice when we're finding the vertical leg or the horizontal leg, we can just count, all right, on those, right? So we can count our boxes, our units, and so notice here, all right, just make sure you're aware that this is kind of a weird thing because this is like every 2 boxes is 1 here. Okay. All right. And so notice I can count, go 1, 2, 3, 4. So I know this vertical leg is 4, and then my horizontal leg is 1, 2, 3. So I can count, all right, when I have a vertical or horizontal leg. We just count those, right? So we just count whatever that length is, right? And that's another great thing about drawing that right triangle in. We give 2 legs that are very easy to count, right? And notice this is our distance right here. That's what we want to find, all right, that hypotenuse. All right, so now, all right, we just go right into the Pythagorean theorem, right? So 3 squared plus 4 squared equals d squared. All right, and notice I can't just count these, right, because I don't have the nice little boxes. It's not really tidy here to count those. All right, and then I just go through all of that, right? So 9 plus 16 equals d squared, 25 equals d squared, take the square root of both sides, all right, and I can see that this is 5 units. And notice, it doesn't look like I'm counting 5 boxes here, right? And it's kind of hard to tell, right? So that's why we need something that's exact like this. And not every distance is going to come out to be a whole number either. So that would make it really difficult if I have, 6.78 boxes. You're not going to be able to really tell that from the graph anyhow. All right, so, all right, how do we do this? All right, we're going to use the Pythagorean theorem to find distance. So we want to plot both points you want to find the distance between. So let's go back to this example here. Negative 3, 4, 1, 2, 3, 1, 2, 3, 4. So there's my first point, and 2, 3, right? 2, 1, 2, 3. All right, okay. We want to find their vertical and horizontal distances. All right, creating our right triangle. And so notice, I'm just going to draw this in right here. So that's 1, 1, 2, 3. I plotted the point wrong. Oh, I did. So, all right, we're going to change it just for my example here. Negative 2, 4. All right. So 1, 2, 1, 2, 3, 4. All right. Okay. And so then that's a 4 right there. And then we can draw this in right here. Okay. And that's the D part. And then we want to use the Pythagorean theorem. All right, to solve for the missing distance. All right, and if it's already horizontal and vertical, we can just count that distance, right? So if I had, what's the distance between these 2 points, right? It's just 1, 2, 3, it's 3. All right, so if it's vertical or horizontal, right, you can just count the distance, right? 1, 2, 3, 4, 5. All right, so no big deal there. So we only have to go through this process if we are not finding the distance of a horizontal or vertical line. All right, so let's look at the next page and let's go through a couple of examples together here. All right, so we want to find the distance between the points graphed below. So I want to find this distance in problem 2 right here. All right, so create our right triangle. So I'm going to just drop a vertical length and a horizontal length to form our right triangle. And so notice there's our right angle, right? And then that means D is the hypotenuse because it's the side opposite that right angle. And if I look, 1, 2, 3, 4, 5 is my vertical, or excuse me, my horizontal leg, and then 1, 2, 3, 4, 1, 2, 3, 4, make sure I count that right, is our vertical leg there. Okay, and so, all right, now we can just jump right into the Pythagorean theorem, right? 5 squared plus 4 squared equals D squared. all right? And we just go right through that, right? So 25 plus 16 is equal to d squared, all right? And that is 41 equals d squared. Let me grab my calculator here. All right, back into the screen here. All right, and so once again, on your calculator, right, so second square root, so you want that symbol. So on my calculator, all right, it's that guy right there. All right, and then we put that in, so 41, 6.4 is our distance. So 6.4 is equal to D. All right, and so that's all you have to do. All right, let's do one more together. All right, let's look like number 3 here. So find the distance between those points. All right, so we want that straight distance between A and B, so that guy right there. All right, that's what we want. So once again, we're just going to create our right triangle. So I'm just going to drop my vertical leg and my horizontal leg until they meet. And where they meet is where that right angle is going to be formed. And we just have to find the length of those two legs, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10, all right, for my vertical leg. And then 1, 2, 3, 4, 5, 6, 7, all right, for my horizontal leg. And once I've done that, now it's just right into our Pythagorean theorem, right? So, all right, 7 squared plus 10 squared equals d squared. 49 plus 100 equals d squared. And so 149 is equal to d squared. All right, take that square root of both sides. And I can see that my length of this segment would be 12.2. And I didn't do that on screen, but I'll show you there. There you go, square root of 149, 12.2. And that's all the distance is. It's really just Pythagorean theorem. All right, so hopefully you feel comfortable with that. We'll continue to do a little bit more practice in class. You guys have a good night. I'll see you.